This week we continue our exploration of Boeing's history. We'll see how two jumbo jets were destroyed in the endeavour to see just how safe a jumbo actually is. We'll also discover how the world's largest factory was built and how previous production set the scene for the jumbo's development. During the early 1960s, the US Air Force asked for tenders to build and supply a big transport. It was believed that Boeing had the edge over its competitors Lockheed and Douglas. However, in 1965, the Air Force announced Lockheed had won the bid with their C-5 Galaxy. But Boeing's misfortune at losing the contract was a factor that assisted them to create the 747 Jumbo. This plane broke nearly every previous commercial aviation record. One example is the Qantas flight on August 16, 1989. A new 747-400, the latest model, touched down at Australia's Sydney International Airport. This plane had just flown 11,200 miles from London in 29 hours, 9 minutes and 5 seconds. This was the longest airline flight in history. The technology Boeing used to build the Jumbo was accumulated over many years, mainly from building bombers for the US Air Force during the war years. One example is the B-29. An American propaganda film claimed there was enough stored aluminium sheeting to lay a silver carpet over every street in Tokyo. Whether that's true or not is hard to determine. Another claim is that there were 50 tons of blueprint drawings created to build the plane. The B-29 could claim a number of firsts in aviation. However, it's the wing that stands out as a milestone in aircraft development. It had a revolutionary set of flaps that occupied about 20% of the total wing area. This reduced the stall speed of the plane, hence reducing its landing speed. The B-29 could land in as much distance as aircraft half its size. Boeing's success is not derived just from flight innovation. The techniques Boeing developed in the building of aircraft is the other ingredient of their success. Shuffling assembled components around the factory floor was time-consuming and space-consuming. Boeing developed the overhead transportation system to speed up production. This system is still used today. The power plant for the B-29 was 4 2200 horsepower engines, which gave the plane an accumulative power of 8,800 horsepower. This gave the plane a flight speed of more than 300 miles per hour. Another revolution was the development in the fuselage. It was pressurized. This allowed the plane to fly at great heights. After the war, Boeing transformed the plane into the Stratocruiser. It's the accumulation of such achievements which allowed Boeing to take future gambles and win. On July 25, 1966, Boeing took on the first physical stage of building the world's largest commercial aircraft. They chose this site to do it. But before the construction of the plane took place, they had to build the world's largest factory. The site is Everett, which is approximately 49 miles to the north of Seattle. A total of 630 acres of heavy forest had to be cleared. More than 250 contractors were required for this operation. More than 2,800 men and just about every construction vehicle were employed. Along with the clearing, a railway was required. It's America's second steepest, and it rises 500 feet in less than 3 miles. The cost of the railway alone was $2 million. Initially, it was used to remove rubbish and supply materials for the construction of the building, and later it would be used to bring in parts and materials for jumbo jets. There were always problems to overcome, but one in particular nearly delayed the project, and it seemed there was little anybody could do about it. It rained for 68 days straight. Machinery and people sat idle, and this was becoming extremely costly. To overcome this problem, Boeing asphalted about 100 acres so that building could continue as planned, regardless of weather conditions. The building was behind schedule, but even that didn't slow Boeing's determination to finish the plane on time. They simply decided to construct the building around the prototype 747. The plane's construction team had to wear hard hats and brave the cold, as the building was still open at one end. What the entire team achieved and overcame was incredible, and that is what they became known as, the Incredibles. As the building of the plane commenced, the train became even busier. Not only was it still bringing in building materials, it was also delivering plane components. The train transported the 1 million or so components right to the factory floor. The factory itself resembled a mini city, 48 acres in size, under one continuous roof. Prior to starting the building, much research and development had to be done to confirm exactly what Boeing wanted to create. Thousands of hours were spent on wind tunnel tests and on paper designs to reduce drag as much as possible. Drag determines the plane's fuel usage, and this equates to money. For the 747 to be a success, it had to be economical to operate. Over the months, many designs were tested, including this double-decker version. Millions of dollars were spent on wind tunnel tests, and every parameter was measured and recorded. In the meantime, a flight simulator was developed to train pilots to fly this Leviathan. The simulator was a TV camera that scanned a detailed and accurate model. The flight characteristics were the tricky part, and the programmers could only set parameters for how the engineers thought the plane would behave. The praying mantis was built to give pilots a hands-on experience in taxiing the plane, 29 feet in the air. Jack Weddall, Qantas's chief test pilot, developed the idea, and with practice he could maneuver the mantis to within 6 inches of the loading platform. This was a very important test, as it proved that the 747 could be managed at airports without major changes to existing infrastructure. A full-scale mock-up of the 747 was built to test every part and component of the plane. Basically, the first 747 was nothing more than an engineering tool. Components were arriving from contract companies both nationally and internationally. When full production began, all 4.5 million parts had to arrive on time, every time. The logistics were as huge as the plane itself. The mock-up showed the first flaws. Here is the first jumbo coming together. This is the big test as the millions of pieces are assembled. What we're witnessing is theory being tested in practice and a plane becoming reality. The tolerance of the engineering process had never been so stringent in aircraft manufacture. The Incredibles had overcome many obstacles to get the plane to this point, and the tension was heavy, as this was the make or break point of their commitment. Over 75,000 engineering drawings were used, and each assembly instruction had to be followed to the letter. Many systems on the jumbo were duplicated as backup systems, and to get the plane together for the big presentation day was a colossal job. It was not only the large parts of the jigsaw that had to fit, it was the millions of small pieces that also had to fit and operate perfectly. The first two operational planes were created just to be destroyed in one of the world's most expensive destructive testing exercises. It wasn't smooth flying for Boeing. There were some problems. The prototype 747 was rolled out to an astonished crowd of workers, reporters, and airline executives. While everyone knew Boeing was working on a jumbo jet, no one was quite ready to accept the real size of the plane.
1, 2, 3. Got it? Okay, wait!
The size was in fact the first problem. The first jumbo was overweight by 240,000 pounds. It was estimated in the design to weigh only 550,000 pounds. On February 9, 1969, the second 747 prototype did fly. The second prototype was a leaner version. It weighed 630,000 pounds and was becoming workable. Flights between February and December revealed an engine problem. They were underpowered for the increasing weight and size that had occurred since earlier designs. However, the engine problem hadn't been solved by the time the plane entered service in January 1970. At one stage, Boeing had about 30 planes parked at its plant that could not be delivered until Pratt & Whitney had corrected the deficiencies of its JT-9D engine. It took a year before the engine problems were rectified. This is a wing flying for the equivalent of 30 years. This is a wing breaking after being pushed 29 feet upwards. One test saw the tail of the plane dragged along the runway until the plane actually reached its minimum unstick speed. Undoubtedly, the tail wouldn't hit the ground in commercial use. The rejected takeoff test is another interesting experience for the test pilot. The brakes are locked up and the plane is given full throttle down the runway. First, the tyres blow, then the undercarriage gives way, and finally, the fire starts. Anti-lock brakes that are now common on cars have been used on the Jumbo from the beginning. Another test is to land the plane with a number of wheels locked up and the remainder left as designed. It also demonstrated what would happen if a braking malfunction occurred. The 707 passed a remarkable test. An underwater tank held an entire fuselage and pressure was exerted on the plane, which was calculated to be the equivalent of 40 years of flying or 50,000 flight cycles. The plane was intentionally damaged in certain areas to see how long such damage could sustain long-term flight. Amongst the final tests of the 707 was the placing of barrels of water in the plane. Barrels were to simulate the weight of 180 passengers or 45,000 pounds of payload. Another 9 tons was added just to see if the plane could sustain such an overload. The total weight of the plane was 360,000 pounds. The ground engineers recorded all the vital statistics of the tests, including the performance of individual components and flight characteristics. Over 35 days of flight tests, the pilots flew the plane from very low levels to very high altitudes at speeds ranging from near stall to over 700 miles per hour. The plane and test results were handed to the FAA for their testing and certification. The biggest compliment to Boeing regarding both the safety of the plane and its capabilities occurred in December 1959, when an Air Force C-17A landed in Rome. The plane had President Eisenhower on board, and he was on a mission called Monsoon. The president was going to visit 11 countries in 19 days. Such a journey on the best plane previous to the 707 would have taken at least a month. This was a clear signal to the world that the jet age was here. In India, Eisenhower visited the Taj Mahal with President Nehru. When he arrived in Athens via Tehran, he had covered the entire rule of Alexander the Great in just one day's travel. He went on through France, Spain and Morocco before returning to the United States. The trip was an absolute success. Huge crowds met him wherever he went, and they also saw the future of flight in the Boeing 707. Today, with planes derived from the 707's remarkable achievements, many people have the opportunity to follow in President Eisenhower's footsteps and travel to places that once seemed so far away. Another milestone for Boeing and its greatest advertisement. The plane that carried the presidents was designated Air Force One, a Boeing 707. These planes carried every president from Eisenhower to Reagan. The saddest moment for this Air Force One was the day it returned the body of President Kennedy to Washington after his assassination. The name Air Force One, passed from plane to plane, is actually a radio call sign and is used only when a president is on board. The VC-137s were fitted out luxuriously, and the seating was for only 22 passengers. They also had advanced navigation and communication systems, but apart from that, the plane was comparable to a commercial airliner. It was so popular that within the first 12 months of service, more than 2 million passengers had been carried. For those days, this was a staggering amount. In Australia, Qantas opened a service from Sydney to San Francisco. This was only one of many new routes that opened up around the world, and it was only possible because of the Boeing 707. Qantas was under much pressure to buy from British manufacturers, but they chose the 707 because Boeing had designed a short-body version of the plane especially for them, so that it could operate from Sydney's short runway and the other short runways of Qantas destinations. Join us again on our next search through our brief but fascinating history of flight and aviation. Come with us and meet the people, the planes and the companies that have created the world's most technologically advanced machines. That concludes another episode of Flying Through Time. Join us again next when we further delve into our short but colourful history of flight.